Alright, here we're asked to add or subtract these radicals, and the logic that guides us here is essentially the same logic that guides us when we're working with variables. And that is to say, I'll refer to the variables after I solve this right here. I don't know exactly what radical 3 is. That is, I don't know what times itself gives me a 3, but I know that it's identical to this one, which is radical 3. Okay? The signs are the same. They're asking us to add. They're both positive. And if nothing's written in front, it's assumed that there is a 1 there. Okay? If there's a 5 or a 9 or a -2, whatever, that's what's present. But if nothing is written, just as with variables, it's assumed that there is a 1. Okay, well, I know that I have 1 plus 1, or 2, of these green boxes, and the boxes happen to contain radical 3. So this is the answer to this expression here. Okay, and I'll make the comparison to algebra. If you have x plus x, all right, it's understood that there's a leading coefficient of 1 for each variable. So I can add these, and I would get 2x. Okay, so it's the same logic. I don't know what x is, but I know that I have 2 of them. All right, and just as, let me slide this over a little. Just as I would, if I had, let's say, x plus y, I'll need my, whoops, plus sign here. There's no way to add them because they're not like terms. All right. So if I had, let's say, radical 3 plus, let's just say radical 5, there's no way to add them. Okay, so this would be the simplest form you could come up with. Okay, so in order to add or subtract radicals, they have to be identical. And let's see how that plays out. And now taking a look at number 44 here, we have radical 13 and radical 13. We'll be able to add or subtract. The signs are different. We'll be subtracting, and you need to keep in mind there is a 1 in front of the radical 13. So if I have a positive 1, a negative 5, when I combine them, I'll get -4, and I'll simply keep the radical 13. Okay, so you'll have -4 radical 13. By the way, a number in front of the radical indicates it's to multiply, and that's the same as a number in front of any grouping symbol. A number in front of parentheses means you're to multiply. Okay, but we can't really multiply in this form. We're just going to leave it like that. Okay, if you take a look down here at let's say 46 and 47, we're not able to add or subtract the way these are written presently because you don't have the exact same thing under the radical. Okay, so we'll try to simplify what we have under the radical and then see if we can add or subtract. And let me get a different sheet for that. Alright, so we will take a look at number 47 here. And let's get our directions in view. Alright. So for 47, they do want us to add or subtract. We have 1 positive and 2 negatives, but you have to have the exact same thing under the radical. Okay, so first we'll tackle this first one. 24, is there a perfect square lurking within? 24 can be written as 4 times 6, and 4 is a perfect square. Okay, so I think I'll just work horizontally here. Excuse me, vertically. I'm going to work these vertically. Alright, so 24 can be written as 4 times 6. Alright, so I'll keep that. Notice it's still under the radical sign. Bring down this minus right here, and the 9. Okay, and this radical sign. And let's see if we can come up with something for our 96. Okay. So 96, if you can't just think of the perfect square lurking within, you write 96 and start listing all the factors. So I'm going to see if I can shortcut this a little bit, and I have a feeling I'm going to run out of room pretty quickly. So we'll zoom out some. So let's see, for the 96, I feel like no matter where I go I'm going to run out of room. 1 times 96 certainly won't help us. 2 times 48 still won't help. 3 times 32 still won't help. 4 times, so let's see, if 2 times 48 gave us 96, then 4 times 24, and if I keep going, I'm going to find out that something times 16 will work. But if you notice, this 24 could be written as 4 times 6, and that would give me 2 of a kind. So I'm going to rewrite 96 as 4 times 4 times 6. 4 times 4 times 6. Excuse me. And 4 times 4, that's as good as having a perfect square because it's 2 of a kind. Okay, I could just as easily have written 16 times 6, but the way I was listing my factors, this was easier to spot. Okay, then we'll continue along rewriting our original expression. Okay, so this minus sign is right here, and the 2, and then the radical, and we'll see if we can rewrite 150. Alright, so 150, this can be written as, I hope things that are divisible by 25 are kind of jumping out at you, and in fact this is divisible by, well, if I write 3 times 50, I still don't have a perfect square, do I? But 25 is a perfect square, so 150 can be written as 3 times 3 times. How about 6 times 50? That's 300. Oh, I was looking at the 25s. I'm sorry. So let's see. And it wouldn't be 6 times 50 either. It would just be 3 times 50. But I really want the 25s, okay? So 150 can be written as 6 times 25. Okay? And I'm trying to shortcut this process. If you feel uneasy about just thinking through the factors, simply write your 150 and start listing all the factors. 150, 2 times 75, 3 times 50, 4 won't work, etc. But I'm just trying to shortcut the process, okay? 6 times 25 is going to work, so I'm going to write 25 times 6, and that's just because I tend to like putting my perfect squares, in a sense, almost out. And now let's just see what we have. I think I'll try using 2 pens for this so I can move it along. 4 is a perfect square. The square root of 4 is 2, and we have radical 6, kind of trapped. I think I better get some more paper. Alright, so we'll sort of repeat what we did here. Square root of 4 is 2, and we have radical 6. Bring down our minus 9. Okay. 2 of a kind. 4 times 4 is 16. So we bring out a 4. And this radical 6 is still trapped, so to speak. Bring down our negative 2. And the square root of 25 is 5. And again, we have our 6 trapped under the radical. Okay. So what is this? We have 2, we have negative 36, and we have negative 10. Each of these with radical 6. And I'm going to have to push it up. Yeah, this will fit. Alright, so if I have 2 and negative 36, that'd be negative 34. Negative 10 would be negative 44. And we just keep our radical 6. Alright, let me double check that real fast. Okay, it looks real good. So that takes care of number 47. And we will also tackle number 49 because we have variables in there as well. Okay. And looking at number 49, it's essentially the same process. I want the exact same thing under the radical. And maybe I can zoom in to start. So this is going to stay the way it is. 5 and x, there's no way to get any of that out from under the radical. But here, 45, we could rewrite that 45 as 9 times 5. Okay, that's 45. Okay, all I did was rewrite it. And x to the third, I can rewrite x to the third as x squared times x. Excuse me. Again, I don't need this dot here because a variable next to a variable means to multiply. I guess I just put it in there for emphasis. Alright, so all I've done so far is rewrite what's underneath this radical sign. Alright, so I'll put the radical sign in place. The 3 is sitting in front. This plus sign. And then in front here, we have x times radical 5x. we'll turn our attention over here now. So I'll bring down this plus 7x, and let's see if we can rewrite what's under the radical. The 45, all right, this 45 can be written as 9 times 5, and the x is just going to come down as it is. I can't break that up at all. And now let's see what we can get out from under the radical, okay? This first one, nothing will come out. Over here, the square root of 9 is 3. The square root of x squared is x. Over here, the square root of 9 is 3, and this 5x will be trapped under there. So we now have x radical 5x plus 3 times what we got out from under the radical. And then what is still trapped under there is a 5 and a x. Okay, notice it's the same here. And then over here we'll bring down our plus sign, our 7x. And it's going to look kind of strange if I write 7x times 3. So I'll put 7 times 3, and I'll put the x behind the 3, okay? All 3 of these things are being multiplied, so it doesn't matter what order I write them in. I just did that in the hopes that it was easier to read. And we still have a 5 and an x trapped underneath. So we have 9x, we have 21x, and we have, this is really a 1x, right? So I'm just going to put x, but keep in mind that's a 1. And then we have radical 5x, this plus sign, radical 5x, and radical 5x. And I want to mention, the more you can do this in your mind, the better off you're going to be, I suspect, because you can see it gets very cluttered when you try to show everything that you're doing. I'm just trying to be very explicit here, okay? Fortunately, all the signs are positive, so I'm just going to add them. 9 and 1 is 10. 21, that makes 31. X, the x just comes along for the ride, as does the radical 5x. So that would be your answer for number 49.